Good morning, students. Welcome to the next lecture of Biomedical Engineering. My name is TSS Nagapavan Kumar. Today we will see the concept of methods of accident prevention and power distribution system in the hospitals. Okay. In the previous session we have seen shock hazards from the electrical equipment. The topic is which explains different types of shock hazards in the hospitals. In this present lecture we will continue the same topic for providing different types of accident prevention methods. Okay, so see here, coming to that methods of accident preventions. So here we have various types of methods of accident prevention. The first one, earthing, that is providing the proper grounding connections. Second one, double insulation. So whichever the cables we are using for the medical operation purposes, we are using double insulated cables. Next, protection by low voltage. For load, due to the low voltage also there may be a chance of happening electrical accidents. So for that reason, protection by low voltages. And coming to that fourth one, ground fault circuit interrupts. So most of the situations, I think we are providing perfectly when the building is constructed, but due to the lack of maintenance, sometimes the earthing connection is going to be break up. So at that time we have to identify the proper grounding breaking connection. That is ground faults we have to identify, and we have to provide a circuit breaker to avoid these electrical accidents. And the last one, isolation of patient connected parts. So whichever the electronic equipment or biomedical related equipment we are using for treating the patient, we have to provide some isolated equipment which will reduce this leakages of electrical current. Let us see this concept. So in the previous concepts we have seen there is a shock hazard which we are using only phase and neutral wires. So when we are connecting only two wires, one is line conductor and another one is neutral conductor. If you are using these two lines, there may be a chance of electrical leakages. So at that time we are now the grounding option, the electrical leakages will select the discharging path to the ground by the human body. So we have to avoid for this one. So this is not suitable connectivity for all the machineries. So without grounding, if the phase and neutral wires are only available, then it is not suggestible. Now, so let us coming to that, we have to provide a 3-pin sockets or 3-pin plugs. We are coming to this, in this one side is phase, one side is the line conductor, another side is the neutral one, and third pin is the ground pin. So these 3 pins we have to use for any type of equipment to construct or to operate the equipment safely without any electrical accidents. So now we have to connect the 3-pin sockets to all the machineries. So this is the correct way of utilization of all the medical equipment. So this is the correct way of connecting all the medical equipments to operate in a safe mode. Okay, right. Next, so next coming to that, the 3 type of pin connectivity. Coming to that circuit diagram point of view here, how the connection will be available. So here the patient is available. So this is a patient connected box, whichever the equipment we are dealing, that equipment box. In this box we have different types of electronic circuitry operating circuits. So one side we are using a phase wire, that is we are representing with some red color. This is the phase wire, and we are representing the neutral wire. Here one more, this is the neutral wire. This is the neutral wire. Okay, so the phase wire and neutral wire. So this phase and neutral wire are connected to a box that is an electronic equipment. So this electronic equipment, in this electronic equipment, if is there any leakages, these leakages will be distributed over all that medical equipment. So now I am representing a ground separate cable, This is the ground separate cable. This is the a ground separate cable. Here I am taking this ground separated cable. Here I am connecting to the box. If is there any electrical leakages, these electrical leakages now chooses this path. The electrical leakages now chooses this path to discharge the electrical leakage. The electrical leakages chooses this path to ground, to discharge to the ground in this path. Now there is no chance of passing these electrical leakages to the human body. So if the electrical complete outer box is connected to the proper grounding connections with a separate line other than the phase and neutral, if is there any special line, then no electrical leakages may not be caused to these electrical accidents. So maximum, this is the one of the method which we are providing for the safety of the patient. Okay, so this is the first method. Next, coming to that, after grounding. Okay, this is the theoretical explanation for this grounding. Proper earthing or grounding of the equipment is good production method. The ground resistance Rg. So whichever the resistance we are using, whichever the resistance here we are using, this grounding connection, we are representing the resistance with Rg. It is as much as low. The Rg value is as much as low. So small that the fault current most of the times it flows through this ground path. This is ground path. If the resistance of the ground connection is very less, then automatically the electrical leakage chooses that path. Where in case of connected to ground through a conductor, protection against the earthing problem is hospital grade receptacles and plugs normally marked as a green dot. Provision of protection by using tripping of circuit breakers. So in the most of the situations, we are providing these grounding connections in the hospitals in the specific operating point also by using a green dot representation. Right. Now coming to here, the second method of avoiding this electrical accident is double insulation method. So here the electrical copper wire is covered with red color and blue color wires, and these two wires are coated with another insulating material that is with a black color wire. So this is the double insulated wires. Okay, this double insulated wires we have in this two different methodology. So one is individual wires has double coating, and the single coated wires has common double coating method. So here the two wires has so first of all they have individual insulating one layer, and they have common insulating layer, that is black color wire in this picture. In this picture we have two separate cables are there. For each cable two different insulating layers are available. The equipment case may be made of suitable plastic or wherever conductive parts exist, they are further insulated from the main box or case. So whichever the electrical wires we are manufacturing, these wires are, we have to provide another insulating plastic box or any plastic wires separately. This is all to ensure RF fault resistance as high as possible. So whatever the fault resistance it will be available, this fault resistance if you kept very high, then there is a chance of to avoid the electrical accidents. Double insulation is generally useful for handheld tools. So double insulation is very used and very convenient method to use handling the tools. There should be sufficient safeguard by making it waterproof also. So sometimes there may be a chance of rainfall or water leakages also caused these electrical accidents. We can avoid those situations also by using this double coated wires, double insulating wires. Right. Now coming to that, the third one, this is protection by low voltage. So the production by low voltage. So in some situations there may be low voltages are caused due to the heavy electrons collisions flow in the electrical wires. At that time unwanted temperatures will be generated at the electrical wires. Due to that unwanted temperature, the heat in between the electrical wires are going to be high. At that time the electrical insulation wires due to the heavy temperature, the insulation of the electrical wires melted, and there may be a cause of getting electrical accident with that wires. So for that reason we have to check in all the situations at the electrical wires what is the temperature is available at the electrical wires. So the operation of the medical equipment from battery is safer. However, it is limited to equipment such as flashlights and tracers. So many medical equipment we are using completely by the direct power supply. So when you are connected to the direct power supply, there may be caused a lot of electrical fluctuations or low voltages. There may be caused electrical accident. So for that reason, better we have to use portable instruments. So battery operated devices are the better or safer in most of the situations. However, large machines like X-rays cannot be operated from the batteries. So some of the instruments like X-rays, CT scans, MRIs, these are the instruments we cannot use with the batteries. Okay, so like ECG machine we can operate with battery. For example, temperature checking thermometer we can use a small machine with a battery operated device. Like that, so many machineries we can use with a battery power supply. Okay, right. Next, ground fault circuit interrupter. So many hospitals and so many organizations where they are saying that we provided a perfect grounding system, but it is unexpectedly it is going to be failed. So the ground connection is broken and the electrical accident will be happened like this. So these type of physical damages, this type of unwanted circuit breaks we cannot expect all the times. So for that reason we have to provide a special circuit. We have to provide a special circuit to protect this type of electrical accidents. We have to provide a special type of circuit interrupter to identify the ground faults. Okay, the grounding is very important. If the grounding is not good due to some unexpected situations, then electrical accidents will be happen. So for eliminating the electrical accidents, we have to identify the ground faults priorly. So for that reason, we have to use a ground fault interrupters. So this is the previous example we have discussed. In this situation, the proper grounding is not there. This proper grounding wire, see here we have a grounded wire, but this ground wire is broken unexpectedly. Here we have provided a ground connection from the box to ground, but the ground connection is broken in this situation. Okay, right. In the case of fault of figure, the body of the operator is a conductive path to the ground. So at that time, electrical accidents will be happened. Most of the current entering the equipment through the live wire returns through the neutral wire, and part of the current returns through the body to the operator and the earth. Some of the current is passed through the human body, then electrical accident will happen. So for that reason, we are providing a ground circuit fault interrupter. In this ground fault circuit interrupter, we have a test and reset buttons. So when we are operating that machine, we have a test and reset options. If any circuit will be broken, we have to bypass that. That means we are providing two ground connections from this circuit fault interrupter. If any ground connection is failed, we can use this test operation and reset operation. So with this test and reset operations, we can bypass that ground connection from one wire to another wire. The ground fault circuit interrupter monitors the current flowing from live wire through the neutral and also through the earthing path by differential transformer and electronic amplifier. So these electronic interrupters always monitors how the current flow is going from line conductor the neutral wire, and the electrical leakages, how this current is passing through the ground wire. All these informations will be monitored by using this ground fault circuit interrupters. If this difference is exceeds say 5 millivolts, if any current leakages will be exceeds more than 5 millivolts, then the power supply is interrupted by a circuit breaker. So then the complete power supply circuit will be interrupted by using a circuit breaker very rapidly, such that the operator saved from the large current flow from harmful effects of the time duration. So in that time duration, is there any some chance to get a lot of electrical flow and damages in the wealth point of view and then the point of health also. So for that reason, we are providing these circuit breakers to avoid that type of situations. So by using some threshold current of 5 millivolts. So this is an example of circuit breaker picture. In the circuit breaker picture, we have a test button, we have a reset button, and we have some hot terminals, we have the ground terminal, and these are the circuit connecting part to the wall. This is a circuit test. If the power stops flowing when this button is pressed, then the device is working properly. So some fault is identified. If the fault is after identification, it is intimated to the operator. The operator will come and rectify that problem, and he uses this test button. This test button will reconducts again the paths and it will again works normally after clearing the problem. This reset button we are using to set the all the situations into the previous stage. And this is the fourth one. So first one we have seen grounding, second one double insulation, and third one we have seen protection by low voltage, and fourth one we have seen ground circuit fault interrupter, and fifth one is isolation power distributed system. The fifth one is isolation of power distributed system or patient connected parts. So see here, this is an example of ECG machine. In this ECG machine, here we have the power supply, here we have the modulator, here we have the differential amplifier, where this differential amplifier is collecting the patient data from the patient leads. Next, patient leads. So this is the box which is representing the modulator, and this complete block is kept in a isolated input amplifier. This is the isolated input amplifier. Generally, the isolation is the term which is explains it allows the flow of current in one direction only. It will not allows the current flow in the reverse direction. Okay, there is no leakages of currents. If there is any leakage current, it is going to stop there only. So this is the isolated connectivity part, isolation transformer connectivity part. Already we have a transformer or a rectifier circuit internally, but this is an extra safety case. And here we have an amplifier. This amplifier, here we have amplifier, here a carry generator, and here we have a power supply, and here we have a filter circuit, here we have a demodulator. So this is the present day ECG machine showing isolation using transformer. So by using isolation transformer, we are providing the isolation concept to the ECG machine. Isolation concept to the ECG machine. Okay, this is the isolation of patient connected parts. So where the patient connected parts means the electrical wires or electrodes we are connecting to the patient. So these are the electrical leads, that is RA, LA, LL, RL. These are the four wires we are connecting to the patient. These patient connected wires we are keeping the patient connected wires. The patient connected wires we are keeping. The patient connected wires we are keeping in a separate box, that is which is protected by the isolation transformer. Okay. Now, whichever the current is coming from this power supply, it is protected. The power supply is completely protected, and this cannot be transferred to the patient. This is one type of isolation for the ECG machine. Now, machine side we have provided isolation. Now coming to the patient side, we have to provide the isolation. So see here we have a differential amplifier here. For this differential amplifier we are connected to the two terminals to the human body, and here the earth connection, the ground connection, the fourth one reference connection also we have connected here. Right now, from from when we are taking some signal from the human body, at that time we are exciting the human body, so with using some minimum voltages of DC supply. So when we are exciting the body, then only we can get the signals or information from the body. So this is the normal connectivity part. Okay, this is the normal connectivity situations. This is a normal connectivity situations. In this situation, when we are exciting, there may be a chance. When we are exciting the patient body parts, connected parts, there may be chance of getting unwanted leakages currents flow through the human body. So for that reason, here we are using current limiters. So whichever the wire which is connected to the human, each wire which is connected to the patient, each wire we are using some current limiters. So some excess current, when it is transferring from power supply to the human body, when you are exciting, these current limiters will identify how much current is flowing from power supply to the human body. They will identify. So when excess amount of current is coming from the power supply, this current limiter limits that current for not passing to the human body. So like this we can avoid that excess amount of currents by using this current limiters. So this is another part of isolation circuits providing to the human body. So this is a isolation of patient connected parts. In this next concept we have seen isolation of machine connected parts. In this concept we have seen. Now coming to that, patient side we have completed, and equipment side also we have completed. Which equipment where you going to measure some of the physiological parameters from the human body. Now this is an ICU room. In this ICU room there may be a chance of cause to get electrical accidents from the other equipment, other normal electrical equipment. So ECG machine we have designed with a perfect isolation strategy, and human body connected parts we have provided with a good safety by using the current limiters. What about the remaining electrical equipments which is available in the hospitals? For example, take a room in the ICU. So here the bed. This is the patient bed. This is the patient bed. Okay, this is the patient bed. Right. Now coming to that, next. This is the wash basin. This is the wash basin. Next coming to that, here we have a common reference ground and out cluster system. So all in hospitals, the power, the electrical bulbs or fans or any other instrument are completely connecting to a common junction box, a common junction reference box or ground box. That means all the equipments are grounded by using a single common point. Okay, so this is a normal scenario in the hospitals. If the common ground area, if it is connected with the ground, then there may be a chance of electrical accidents. So, see here, principle of an equipotential grounding system in room or a cubicle and an intensive care system of the cardiac care unit. So, cardiac unit in the ICU, intensive care unit, some cardiology departments are available. In the cardiology department, we have a common grounding. If we have a common grounding system, then all the equipments are connected to the same grounding system. If the grounding system is failure, there may be a chance of any other electrical equipment leakages caused to the patient's electrical accident. So this is one more problem generally we are observing. So for that reason we have to provide a separate grounding connections. So see here, this is one separate connection. Here we have have one separate connection, two separate ground connections we are providing. These grounding connections are operating here 2 to 3 devices. Here it is operating 2 to 3 devices. That means we have to provide parallel grounding connections to the parallelized equipment. That means for low voltages we have to provide separate grounding connection. For high power consuming devices or equipments, we have to provide a separate electrical grounding system. Then the patient may be get in the safe condition. Okay, right. Now coming to that, this is the isolation of power distribution system. So this is the generalized box and power distribution system will be available in the hospitals. In this box, internally one more box is available, but the outer box is called isolation box. So see clearly with some more clarity. So internally we have different types of electrical relays and switches. All these are connected with a board and they were keeping in a box. This outer box we have to provide it with one more isolated box to eliminate the electrical leakages from this power distribution system. And see here, here we have first section, second one, first one, second one, third, fourth, fifth, sixth, seventh, eighth, ninth. Totally we have here 9 different sections for the power distribution mechanism. So one section is handling high voltages. That means one section we are operating with X-ray machines. Another section we are operating with cath labs. The another section we are operating with this different types of CT scan MRI machines. Another section is handling for low voltage devices. Like that we have to provide a parallel systems for handling the total hospital equipment. In the hospitals, in some places we need a very less amount of voltages, in some places we need a high amount of voltages. Particularly in the hospitals, blood bank is available. In the blood bank, we have the deep freezers, which is storing with minus 20 degrees centigrade, minus 30 degrees centigrade, and minus 5 degrees centigrade also. These are the different types of power distributed system. And coming to that leakage current, up to now we are seeing that leakage current. So what is the leakage current in the electrical system? Leakage current is the current that flows through the protective ground conductor. Right. So protective ground conductor to the ground in the absence of grounding connection. So here we are providing the ground connection to protect the complete circuit. So here the grounding connection which is not used in the general cases, there may be causing of the electrical accidents. So whichever the current is flowing through the ground connection, that is called electrical leakage current. It is the current that could flow from any conductive part or the surface of the non-conductive part of the from the non-conductive parts to the ground if a conductive path is available. So generally we are providing some non-conductive paths. At that non-conductive paths some electrical leakage will be available. Then it doesn't have any direction to flow the current. At that time we are going to touch that the equipment, then automatically from that surface we will get the electrical accident. So this type of currents are called leakages currents. For example, this type of conductor such as human body. Next, can you protect yourself from the electricity? We can protect ourselves from the electricity. That is a question. Don't wear the metal objects. When we are wearing the different types of objects, we have to avoid the metal objects. Turn on, power off. When we are operating these devices, we have to first turn off these devices. Then we have to take all the keys. Then we have to start. Wear the appropriate clothings. So the perfect clothings are very, very important. Don't touch the live parts. So wherever the current will be available, that live current pass we don't have to touch. We don't have to that much of enough time. If you touch, automatically you will get electrical accident. Don't install or repair electrical equipment. Use a qualified personnel. Clean and dry leads and plug before you use. So in so many cases, the wet hands or wet areas may be caused to electrical accidents. So first we have to clean all these everything, and then we have to use properly in a perfect way. Next, how do you respond to electrical incidents? If any electrical accidents will happen, then how we have to respond? The first one, if you come across a person receiving an electrical shock, then if possible disconnect the electrical supply. When the patient is getting electrical shock, first we have to disconnect the electrical supply. Assess the situation, never put yourself at risk. Where if possible, you have to call the suitable person. If you have that much of time, then we don't involve into that activity. If any power failure is there, you have to call the electrician. If there any drawbacks is there, you have to call the concerned persons and you have to ask them repair. You do not involve in any type of such activity. Take precautions to protect yourself and anyone else in the vicinity. So first of all, you have to protect yourself and you have to protect others also. Administrator first, and if he is trained, seek urgent medical attention. So you have to check the medical attentions and you have to save the person in time. That is very, very important. And these are some of the symbols in generally hospitals, industries, they will display and for the protecting ourselves. So coming to the first one, this symbol which is representing flammable symbol. So if you are going in this area, there may be a chance of getting some flammable equipments are available. If you go there, you will get some flammable problems. Next, poison. That means here some of the liquids are available. They may be caused to the death because of their poison. And this is the symbol which is representing radioactive elements are available there. So for that reason, you have to protect sufficient suit. Non-ionizing radiation. Some non-ionizing radiations are available here. Don't conduct any metal parts and don't wear any metal items or don't carry any metal items to there. And biohazard. This is representing one more biohazard, and this is representing high voltages, and it is representing use gas mask. In these areas, so many pollutant gases are available. So for that reason, we have to use mask. And risk of explosion. This is representing risk of explosion. This type of symbol generally we can see at the mining sections. Okay, these are the different types of logic symbols are available in the industry side. We have to take precaution from ourselves. Okay, with this we have completed all the methods of accident preventions, and we have seen isolated power distributed systems. Okay, thank you.